Hello, dear students. I'm glad to meet you again in a new lesson. Today, we have a plan to study chapter 4. As we know that we have finished chapter 3. In chapter 3, we've learned many things about the acid and the bases, such as their concentration, their aqueous solution, and how we can identify the acid and the bases according to the theories of Arrhenius, Bronsted, Lowry, and Lewis. And after that, we learned at the general properties of the acid and the bases. Finally, we have studied one of the most important things, which is the neutralization. Today, by chapter 4, we will learn again about the acid and the bases a little more. Okay? Chapter 4 consists of 2 sections. We have 2 sections in chapter 4. Section 1 is about aqueous solution and the concept of pH. Section 2 is about the titration process, which is totally new for you. We don't have any idea about it. But first of all, we have to study about the concept of pH and what we have to study about the pH. Okay. Still now, we know that the only source to providing the hydronium ion concentration is the acid. Well, look, we know that the source of the hydronium ion concentration is the acid. So hydronium ion concentration, we always say that we can obtain this ion when we have aqueous solution of the acid. But now we can see that there is another source to providing the hydronium ion, which is solvent. Okay, water. Water mostly used as a solvent in a chemistry because of it has many desired properties. Well, now we have 2 sources to providing the hydronium ion, which is water and the acid. Okay, now we get 2 sources to providing the hydronium ion concentration, water and the acid. Well, what about the hydroxide ion? Okay, hydroxide ion, normally we get that ion in the aqueous solution of the bases. But again, there is another source that releases the hydroxide ion, which is water. Oh, now we have 2 sources. We have 2 sources to providing the hydronium ion concentration and the hydroxide ion concentration. For the hydronium ion concentration is the acid and base. For the hydroxide concentration is the for the hydronium ion concentration is the acid and water. For the hydroxide concentration is the acid is the base and water. So for H3O we have acid and H2O. For H3O, we have 2 sources, acid and H2O. But for the hydronium ion, OH, we have base and H2O. Well, how we can get hydronium ion and the hydroxide ion from the water? Oh, there is a self-ionization reaction for the water. What is the self-ionization of water? Water, through this process, releases hydronium ion concentration and the hydroxide ion concentration. So we can get hydronium ion and hydroxide ion concentration from the water through self-ionization process of water. But what is the self-ionization of water? Look, we can see that in here we have 2 molecules of water are reacted together. We have 2 molecules of water, they are reacted together to form the hydronium ion and the hydroxide ion concentration. So now, self-ionization, 2 water molecules producing hydronium ion and hydroxide ion. By transferring a proton, one of them acts as a Bronsted Lowry acid and another one acts as a base. Superb. Well, now we have some notes about pure water. What we get in pure water? Well, first of all, the most commonly used unit for molarity is the mole per liter. We have mole per liter as a unit of molarity, and it's symbolized by two parentheses. In pure water, we have equal concentration for both hydronium ion and the hydroxide ion, which they are equal to 10 to the negative 7. 10 to the negative 7. That is molarity. How we know it's molarity? Because we use it. That thing. Well, pure water contains, now because of pure water is a weak electrolyte. So pure water is a weak electrolyte. Right? Pure water is a weak electrolyte. So we can get hydronium ion concentration, hydroxide ion concentration at the molecule by itself. Why? Because of its extremely weak electrolyte. That's why pure water, we can get hydronium, hydroxide, and molecule itself, because of its weak electrolyte. At 25 degrees Celsius, pure water contains hydronium concentration equal to the hydroxide, which is equal to 1 times 10 to the negative 7 molarity. Pure water is extremely poor electrolyte, as I told you, and it's poor conductor because of there's a small number of the ions. We learned that in chapter 1. And now, what is the result of the multiplication hydronium by hydroxide? Look, if we multiply hydronium by the hydroxide concentration called water ionization constant. Water ionization constant. Well, if we multiply hydronium by the hydroxide concentration, we're gonna get 1 times 10 to the negative 40 is water ionization constant. It's very important, and it's useful to converting hydroxide to hydronium or hydronium to hydroxide in terms of the concentration. So we can get the concentration of the hydroxide from the hydronium or hydronium from the hydroxide using Kw equation. So Kw for pure water is equal to 1 times 10 to the negative 40. Kw is directly proportional to the temperature. Is directly proportional to the temperature. Raising temperature, Kw raises. Lowering temperature, Kw lower. Decreases or. And it's constant by changing pressure and concentration. Okay? Now, which factor can influence the value of Kw? As I told you, concentration, no. Pressure, no. Concentration of hydronium, no, because it's constant. It's always 1 times 10 to the negative 40. So what factor can influence the value of Kw? Of course, temperature. Increasing temperature will be increased, decreasing will be decreasing. So Kw at 25 Celsius degree, Kw at 25 Celsius degree is equal to 1 times 10 to the negative 4, T. Now, what about 30 Celsius degree? Oh, that means we increase the temperature by 5 Celsius degree. So increasing temperature, what's going to happen to Kw value? Of course, it will be raised. It will be increased. Good? Now, at 30 Celsius degree, Kw is greater than 1 times 10 to the negative 40. Water ionization constant Kw, so it's constant value at constant temperature. We know that. It's very easy. Now, let's make a chart. Let's make a scale of the hydronium ion. It's very important because it will be the base. It will be the base for pH scale also. So hopefully you get benefit from this scale and understanding each point that I'm going to mention to you. So please write anything that's gonna come out from my mouth. Look, hydronium ion concentration scale. This is scale for hydronium ion concentration. We're gonna identify the aqueous solutions as an acid or base or neutral. Based on what? Based on the hydronium ion concentration. Well, in the middle of that scale is 10 to the negative 7. It relates to, look, to the neutral. It's neutral, okay? So in here we have a neutral, such as water. In neutral, H3O is equal to 10 to the negative 7, OH is equal to 10 to the negative 7, or 10 power minus 7, it doesn't matter how you can read, at 25 Celsius degree. But at any temperature, H3O is equal to OH. So there are two things. This information relates to 25 degrees Celsius. So at 25 Celsius degree, H3O is equal to 1 times 10 to the negative 7, OH is equal to 1 times 10 to the negative 7. But this information is always true. H3O is always equal to OH for neutral. This is always true, but this is true at 25 Celsius degree. Now, in the left side, the acidity increases. So in here we have the maximum acidity strength. But in here we have the lowest acidity strength until the acidity disappears and it's going to be basic. Well, so this range is occupied or it's colonized by the acid property, by the acidity. So if H3O is bigger than 1 times 10 to the negative 7, it's acid. OH smaller than 1 times 10 to the negative 7. So always H3O greater than OH, always. These informations are true at 25 Celsius degree. So now I understand something, teacher. When we mention 25 degrees Celsius, so we have to mention 1 times 10 to the negative 7 for H3O. But other information, no. Look, it's always true. It's always true. It includes 25 Celsius degree even. But this is true only at 25 Celsius degree. Well, now for the right side, the basicity increased. So as much as we get far away from 10 to the negative 7, so we're going to get the most alkaline compound. So that means 1 times 10 to the negative 40 is the most basic compound. Okay? Look. In here we have H3O smaller than 10 to the negative 7, OH bigger than 10 to the negative 7. It's true at 25 Celsius degree, always. This is only at 25 degrees Celsius. This is always true at 25 Celsius degree or degrees Celsius, doesn't matter. So OH always bigger than H3O. But when, if we get basic aqueous solution, but in acid solution, always H3O bigger than OH. Now, let's go through some questions about this chart, and you're going to get more idea about it. It's always true about H3O of the aqueous solution of acid. Oh, what information is always true of aqueous solution of acid, and always true? What information? Look. Always H3O bigger than the hydronium ion concentration. So the answer is H3O is bigger than, is more than the hydroxide ion concentration. You see that? Okay. It's always true about H3O of the aqueous solution of the base. Well, it's base, it's not acid, it's base. It's always true about the H3O of aqueous solution of bases. Well, always OH concentration bigger than the hydronium ion concentration. You see, it's always true. But what you're going to say if that question will be just like that? It's true about the aqueous solution of the acids at 25 Celsius degree. Okay, at 25 Celsius degree, OH smaller than 1 times 10 to the negative 7. H3O bigger than 1 times 10 to the negative 7. And even it's always true, okay? So it relates to the 25 Celsius degree. 1 times 10 to the negative 7. Now, we're going to identify the acidity and the basicity of the solutions based on the hydronium ion concentration. I prefer to always use the hydronium ion concentration. Look, always use hydronium ion concentration in order to deciding that the aqueous solution is the acid or is the base. Well, teacher, but even we can use the hydroxide ion concentration. Okay, my son, it's not important, but you know what I'm thinking about, okay? Because of by passing a time, you will be under pressure. You will have many things to review. So how you can decide by OH? You may confuse. Okay. How? It is bigger than 1 times 10 to the negative 7. Oh, it's acid. No. It's hydroxide. We need to convert it to hydronium ion, then deciding. Look, that's why I'm worried about that. You have to convert your informations to the hydronium ion concentration if it's not. Then decide that the solution is acid or base. How we can convert H3O into hydronium into hydroxide? Teacher, how we can do that? Okay, we have KW equation. This is KW. Okay? In case of hydronium ion concentration known, we can calculate. We can find out OH. Or if OH known, we can find out the hydronium ion concentration. It's very easy. It's just mathematical operation. Well done. Well, for question number 1, or A, if hydronium ion is 1 times 10 to the negative 8, 1 times 10 to the negative 8, in the middle, it was negative 7. In the right side, until negative 40. In the left side, until 10 to 0. So, it locates left side or right side. Oh, teacher, we can find 10 to the negative 8 in here, so it's base. It's base. Okay, it's base. You see that? Okay. 1 times 10 to the negative 4 for the hydronium ion concentration. Oh, teacher, 1 times 10 to the negative 4 is in that side, so it's acid. Well, 1 times 10 to the negative 3, again, it's in that side, it's acid. No. Did you remember what I told you? Don't use hydroxide ion. Always convert the information into hydronium ion concentration. Then you can decide that it's acid or it's base. Well, I know that thing. You told me many times. But please show me how to convert this, how to do that. I need this. Well, look. We have KW equation. It's KW. KW is equal to hydronium times 2 hydroxide is equal to 1 times 10 to the negative 40. So we have the hydroxide ion concentration, 4 times 10 to the negative 3 is equal to that one. So if we need to get the value of hydronium ion, what will happen to that value? It will be to the below of the fraction. Okay, now just use your calculator, you can get the result. Okay, hydronium ion concentration is equal to 10 to the negative 11. It's acid or base. We are sure that we can get 10 to the negative 11 in here. So here is the basicity area, it's the base alkaline area. That's why I prefer to you, please, only use the hydronium ion to deciding the acidity and the basicity. Well, you can do that using hydroxide ion, but you may confuse. Okay, and I'm just afraid about that because of in the final examination there will be a lot of pressure on your mind, so you may confuse. So don't do risky things. The hydronium ion concentration in the solution that is equal to 1 times 10 to the negative 11. Oh, 1 times 10 to the negative 11, it locates to the right side, so it's base. We are sure that it's base. Okay? Oh my God. The hydronium ion concentration of a solution is equal to 1 times 10 to the negative 11. Well, it's the same question, but I prefer to changing that one into hydroxide, OH. Okay, teacher. If we get hydroxide ion concentration by this number, so it's that acid or base. Well, this is hydroxide. We should convert it into hydronium ion concentration. Then we can decide that it's acid or base. Well, just by looking the number, I know hydronium ion is equal to 1 times 10 to the negative 3. Okay, because of, if we multiply these two numbers, we can get 1 times 10 to the negative 40. So it's what? It's acid, teacher. It's acid. Okay. Well, let me tell you something. In any aqueous solution, if you multiply the hydroxide by the hydronium ion concentration, you should get 1 times 10 to the negative 40. Always. Always. In aqueous solution of base, which of the following is true? Which of the following is true? In aqueous solution of base, which of the following is true? Well, it did not mention 25 Celsius, and it did not mention that's always true or not. So let's see the choices. Look, H3O smaller than OH. Aqueous solution of base. H3O smaller than OH. Well, H3O bigger than OH. It's not true. It relates to the acidic solution. H3O is equal to 1 times 10 to the negative 7. No, teacher. It relates to neutral. And OH smaller than, no, even it's base. So the right answer is A. The right answer is A. You see that? It's very easy. Which of the following is a neutral? We know that. Which of the following is a neutral? It's not neutral. It's base. It's look. It's base. It's base also, and that one is acid. So the answer of C is neutral. The answer of C is neutral. H3O is equal to 1 times 10 to the negative 7. Which of the following is an acid? Okay, which of the following is an acid? Dear students, if question gave us a formula of a compound, so we don't need anything to deciding that it's acid or base. We know that HCl is acid, so we don't need the concentration. It's acid by itself. CH3COH, acetic acid, is acid also. So we don't need anything to proving that it's acid or not. We know that. It's the formula for weak acid, which is acetic acid, and it's strong acid, HCl. Well, H3O bigger than, yeah, it's acid also. So the right answer is all of them. It's true about the acids at 25 Celsius degree. Oh, teacher. At 25 Celsius degree, we should choose these answers that includes 1 times 10 to the negative 7. So it's not true. It's not true. At 25 Celsius degree, it's true. Oh, sorry. Because of it's always true. Because of it's always true, so it will be true again. Because of it includes 1 times 10 to the negative 7. It includes 25 Celsius degree also. So it's always true. It's right. And that one is true also. So the right answer is the answer of A and C. Well, when we say is always true, it means even 25 Celsius degree. It's always true, and it's true at 25 Celsius degree. But what will happen if questions say it's true about the acids always? Well, it relates to the 25 Celsius degree, and it's always true. So the right answer is C. The right answer is C. It's only true at 25 Celsius degree. It's not always true. Impure water at 25 Celsius degree. Impure water at 25 Celsius degree. We have this number. We have this number also. So they are equal to each other. All of them is correct. In a neutral solution, H3O is equal to 7. No. 10 to the negative 7. It's not true. Contains neither hydronium nor hydroxide. No. We have both. Has an equal number of hydronium ion and hydroxide ion. Yeah, it's right. None of them? No, of course. So the right answer is C. C. It's right. Now, calculating hydronium and hydroxide ion in the aqueous solution. Well, now we're going to concern with the strong electrolyte in terms of strong acid and strong bases. So in here, we're going to concern only with the strong acid and strong bases to find out to calculating or to getting the number of hydronium and the hydroxide. That's why you have to review how to write the reaction or equation for the strong electrolytes such as strong acid and strong bases in their aqueous solution. Well, we have these two equations. You should know and you should remember anytime. It means that you have to memorize. For strong acids, we should start by calculating the hydronium ion concentration, which is equal to the number of H plus in the acid structure or the number of H3O that we can get through the ionization of that acid times to the concentration of the acid. And for strong bases, we should start by calculating the hydroxide concentration, which is equal to the number of hydroxide times to the concentration of the base. That's why if we have some compound, first of all, we should identify that it's acid or it's base. Then we should decide what we have to calculate firstly, hydronium ion or hydroxide. If the compound is acid, we should find out the hydronium ion firstly, then converting it to hydroxide. But if the compound is the base, we should find out the value of the base of OH, then we can convert it into hydronium ion. So hydronium ion will be for acid, hydroxide ion will be for the base. Then we can make our conversions between them using KW equation. Well, we've learned all of that things, but why it's only for strong electrolytes? Because of we don't know how much, or we don't know how many ions we can get in aqueous solution of weak electrolytes, of weak acid and weak bases. That's why it's not applicable for weak acid and weak bases. So how we can get the value of H3O for weak acids? Well, we should start by practically. There's a pH meter, which is equipment, and it's specialized to find out to calculating the value of pH. Then we can convert pH into hydronium ion concentration, and which I'm going to show you later. So for strong acids, we can calculating directly using their concentration, but for weak acid, we have to use pH meter. Let's do it for that question. If we have aqueous solution of HCl that has a concentration 2 times 10 to the negative 4, well, the compound is acid or base? It's acid. So we should find out hydronium or hydroxide as a first step. Of course, hydronium. So we have to start from the hydronium ion, then converting into hydroxide. Even if the first unknown is hydroxide, we should find out hydronium as a first step. Why? Because of the compound is the acid. Well, find out or calculate the hydronium ion concentration. Well, how we can get the hydronium ion concentration value for the aqueous solution of strong acids? We have this equation. H3O is equal to number of H in the structure of the acid, or in the acid's formula, or I can write the ionization reaction, then we can get the number of hydronium ion. Based on that number of hydronium ion, we can put the number in here. Well, whatever. I think you understand what I mean. Times to the concentration of the acid. Okay, teacher, it's very easy. Now, for HCl, how many atoms of ionizable hydrogen do we have? There's only one. 1 times 2. Its concentration is 2 times 10 to the negative 4. So the answer is hydronium ion is equal to 2 times 10 to the negative 4 molar. It's hydronium ion concentration. Well, we prepared the answer of A. What about B? Okay, we have hydronium ion. Immediately we can get the hydroxide ion using the Kw value. Kw is equal to OH times 2H3O. So now we have a plan to get the value of OH, which is equal to Kw divided by H3O. So OH is equal to 1 times 10 to the negative 40 divided by 2 times 10 to the negative 4. So it will be 0.5 times 2, 10 to the negative 10. 0.5 times 2, 10 to the negative 10. It's very easy. Another question, but there's one more further steps. Well, teacher, we can convert molarity into concentration of hydronium or hydroxide, but what will happen if we get number of mole, even if we have gram? Well, you've learned that in chapter 1, you can convert gram into number of mole, then mole into molarity, then molarity into hydronium or hydroxide. Okay? You see that? Even we need some information from chapter 1. So now we have volume 0.5 for these number of moles of what compound? CaOH by 2. It's acid or base? It's strong base. So choose the one between hydronium and hydroxide. As a first step, it's base, so we need to calculate hydroxide ion concentration as a first step. Then we can convert into hydronium ion concentration. So between hydronium and hydroxide, which the first priority is for hydronium or hydroxide? Of course, hydroxide. Why? Because of the compound is base. So let's find out. OH is equal to number of OH in the base structure, in the base formula, times 2 the concentration of the base. Now is equal to, we have 2 hydroxides ion in this formula, or in the dissociation reaction. It's not ionization, it's ionic compound. We have a dissociation reaction. Well, times 2. Oh, teacher, we need the molarity. But we don't have molarity. We have the number of liter and number of mole. Well, it's very easy. Let's prepare the molarity. We should turn these two informations into molarity. It's very easy. Look, molarity is equal to mole per volume. So molarity is equal to 5 times 10 to the negative 5 dividing by 0.5. Well, it will be 10. It's equal to 10. 10 times 10 to the negative 5. So will be 1 times 10 to negative 4 molar. This is molarity, teacher. Okay, we have molarity. 1 times 10 to the negative 4. So the hydroxide ion concentration is equal to 2 times 10 to the negative 4. It's hydroxide. Well, what about the hydronium ion? Okay, just convert it through Kw equation. I don't want to do that because of we've been using this equation many times. So these equations have the same idea. Now, let's make another scale, but it's not about the hydronium ion concentration. It's about the power of hydrogen or potential of hydrogen, called pH. Well, look. About the hydronium ion concentration, there was sorry. Okay, about the hydronium ion concentration, there was 10 to the negative 7, but in here we have 7. In here we have 10 to the negative 6, in here we have 6. 10 to the negative 5, in here we have 5. 10 to the negative 4, in here we have 4. 10 to the 0, and here we have 0. Oh, teacher, we know that it came from the previous scale, which is about the hydronium ion concentration. So there is a relationship between them, which is logarithmic relationship. Okay, even there was 10 to the negative 40, there was 10 to the negative 30, there was 10 to the negative 8. So we have the same thing for all. Now, if we have any question about the pH, why we get pH 7 for neutral solutions? Okay, because of when we measure the hydronium ion concentration, we have 1 times 10 to the negative 7. You see? Why we get pH scale between 0 to 40? Why? Because of when we measure the hydronium ion concentration, it locates between 10 to 0 until 10 to the negative 40. So if you have any question about the pH, value, we should mention the hydronium ion concentration because of there's a relationship between them, and we're going to learn it now. In this area, there's increasing acidity. For 0, it's maximum acidity. For 6, it's weakest acid, or 6 point something until 7. Now, pH smaller than 7, pOH bigger than 7. What's pOH? Wait. What's pOH? Wait. It's true at 25 Celsius degree, but it's always true of the aqueous solution of the acids, pOH bigger than pH. And here we have neutrals such as water, or neutral salts such as NaCl or KCl or something like that, KNO3. pH is equal to 7, pOH is equal to 7 is true at 25 Celsius degree. pH is always equal to pOH. And for the alkaline area, pH bigger than 7, pOH smaller than 7, it's at 25 Celsius degree. And it's always true about aqueous solution of the bases, which is pH bigger than pOH, always. You see that and here there's the same idea that we learned in the hydronium ion, about the hydronium ion scale. Look, in neutral solution, H3O is equal to, no, there was 10 to the negative 7. It's false. Is that true? No, pH should be equal to 7. No, it's not true. pH is equal to pOH, yes. So the right answer is C, it's not correct. In a neutral solution, pH is equal to 7, yes. pOH is equal to, yes. H3O and OH are equal to each other, so all of them are right. In the aqueous, in the solution that has a pH bigger than 7, oh, pH bigger than 7. It means this side, it's base. Immediately. We don't need to read all of the informations. There's one information is enough to answer that kind of question. pH is bigger than 7. So that means bigger than 7, 8, 9, 10, 11, 12, 30, 40. So they are base. Why does the pH scale range between 0 to 40? Because we get the hydronium ion concentration between 10 to 0 until 10 to the negative 40. And there's a same thing that I mentioned. Now, defining pH and pOH. pOH is the potential of hydrogen and, or hydronium ion is the potential of hydroxide ion. Well, pH is the negative logarithmic relationship with the hydronium ion, but this is with the hydroxide ion. We have these equations. Look, pH is equal to negative logarithm of the hydronium ion, and pOH is equal to negative logarithm of the hydroxide ion. Look, pH plus pOH, pH plus pOH is equal to 40. So for 40 is pKW. H3O times 2 hydronium ion was KW, was a KW. So if we get negative logarithm for KW will be pKW. OH negative logarithm will be pOH. H will be pH. But instead of H, we should write H3O because we cannot get H plus freely in the aqueous solution due to its highly activity power. So you should memorize all these equations. We've learned that there's only 3 new equations. Let's answer. A solution has POH hydroxide number of 4. Did you remember? To deciding that the solution is acid or base, we should use hydronium or hydroxide. Hydronium. And in here, we should use pH instead of POH. Well, POH is equal to 4 converted into pH number. pH plus POH is equal to 40. So if POH is equal to 4, so 40 minus 2, 4, pH is equal to 10. Oh, it's base. Teacher, it's base. It's true about the acids. It's true about the acids. Okay. About the acids. Look, it's true about the acids. Hydronium ion greater than the hydroxide ion, right? Okay, it's right. And hydronium ion greater than 1 times 10 to the negative 7. Well, teacher, it's always true about the acids, and it's true at 25 Celsius degree. So let's write, it's true about the acids at 25 Celsius degree. Well, at 25, at 25 Celsius degree. At 25 Celsius degree, so it's true and it's true. The right answer is answer of A and C. Answer of A and C. Oh, sorry that I corrected many things because of this is older version of my notebook. That's why. So I bring it a wrong copy. Okay, it's old version. Choose the weird answer. About that kind of thing, choose the weird answer. How we can answer this question? Choose the weird answer. It means there are 3 things that are common in some property, but there's one that's different from the others. There's one that's different from the others, and 3 of them have the same property. Look. pH bigger than POH, it means base. Okay. pH is equal to 3, it's acid. S3O greater than 1 times 10 to the negative 3, it's acid. POH is equal to 9, so we should convert it into pH. Now pH is equal to 5, it's acid. So now we get 3 acids with 1 base. Which one is the weird answer? A. A is the weird answer. Now, determining pH and POH. pH and POH for a solution that has a concentration 1 times 10 to the negative 2 molar. Well, teacher, we have to find out the value of pH and POH. And we have strong acid. It's strong acid. And its molarity. So how we can find out pH and POH? We knew that for molarity, from molarity we can get the hydronium ion. So first of all, hydronium ion, H3O, is equal to number of hydrogen times to the concentration. Immediately I'm gonna write and I'm going to run the equation immediately. 1 is number of hydrogen times 2. The concentration is 1 times 10 to the negative 2. So the hydronium ion is equal to 1 times 10 to the negative 2 molar. This is hydronium ion. Okay. Now we have hydronium ion. We can find our pH value immediately. It's very easy. pH is equal to negative log of hydronium ion, which is equal to negative log of 10 to the negative 2. So it will log with log cancel each other, minus with minus. So pH is equal to 2. Now, if we have pH, we can find out POH. POH plus pH is equal to 40. POH is equal to 40 minus 2 is equal to 12. Okay, we get POH also. Just like that, it's very easy. Another question. What is the pH and POH of 1 times 10 to the negative 3 of NaOH? Okay, pH and POH. We have strong base. So, which thing will be the first calculate? Which thing will be the first calculated things? Which thing will be the first thing to be calculated? Oh, we get strong base and the concentration. So we can find out OH immediately. Okay, OH is equal to 1 times 10 because of we get NaOH. NaOH has one OH, so 1 times the concentration, 1 times 10 to the negative 3. So OH is equal to 1 times 10 to negative 3. Okay, teacher, now we get OH. So which one do we prefer to calculate, POH or pH? There's a strong relationship between POH and pH. So POH is equal to negative log of OH and is equal to negative log of 10 to the negative 3. Log with 10, negative with negative, POH is equal to 3. Now we can get the value of pH. pH is equal to 40 minus 3 and is equal to pH is equal to 11. How? 40 minus 3, okay. pH plus POH is equal to 40. I think it's easy for you also. So now we have an idea about that. We can have pH value and converting it into gram. How? Look. pH. From pH we can get H3O. From H3O we can get molarity. From molarity we can get mole. From mole we can get grams. So that's the consequence of solving these questions. Let's do for a question. Let's do this. Hopefully we have a question. Surely we have that one. Okay. Look. Well, we can get the value of H3O from the value of pH. Look, there's a mathematical relationship only. If H3O is equal to 10 to negative 3, so pH is equal to 3. So what will happen if pH is 5? Of course, H3O is equal to 10 to negative 5. You see? Power to number, number to power. That's the relationship between them. Okay? So now if we want to find out, to calculate the hydronium ion concentration from the value of pH, it will be 10 to negative pH, and OH from POH, it will be 10 to negative POH. Okay. We have a question for that kind of thing. That one. Look. Well, it's solved by itself. Actually, I like to solve by myself, but well, it's good also. Look, 2 liters solution of CaOH by 2 that has a pH of 8. Oh, pH is 8. Calculate the mass of CaOH by 2 in gram. Teacher, we have gram. Look, we can change this gram into number of mole. we can change this number of mole into molarity. And then molarity into what? If it's acid, we can convert it into hydronium ion. And if it's base, we can change it into OH. Then we can convert it into POH, and we can get the value of pH. Okay? Well, dear students, I prefer to solve this question in a new lesson because we don't have much more time. So in a new lesson, stay with me, and I'm going to show you how to solve this question briefly. Okay? Because I don't want to do that in a fast way. It takes more further steps than the other questions, so I prefer to do it in a new lecture alone. In this question, we need more further steps. Actually, it takes the longest way to get the aim, to get the answering point, but it's not too difficult. I think it will be easy for you. Just follow my advice, okay? We have this consequence of solving any question in this section. It's just like that, look. Well, I'm doing that according to the longest solving steps. Gram, we can convert number of grams into number of mole. Then we can get number of mole from molarity. If the compound is acid, we can get hydronium ion concentration, H3O, from the molarity. But if a compound is base, we can find out OH. Then POH. And for H3O, we can get pH. You see this? So reverse way is correct. From pH to H3O, from H3O to molarity, molarity to mole, mole to gram. Or from POH to OH, from OH to molarity, molarity into mole, mole in gram. Even we can make a change between them. We have the rule, okay? Because there's not enough space, so I prefer to delete it. Good. Now, 2 liters, a solution of calcium hydroxide that has a pH of 8. Okay, pH is equal to 8. pH is equal to 8. Calculate H3O, OH, and mass. Well, we're going to start from the unknown of number 3 because it includes the other steps also. From gram, how we can go from pH into gram? Is there one step, or it takes multi-step? It's multi-step solving process. Of course, it's multi-step because we should convert pH into H3O. H3O into concentration. Concentration into number of mole. Then mole into gram. Look, 1 step, 2 step, 3 step. The last step is step number 4. So first step, we should calculate the hydronium ion. How we can get the hydronium ion? If pH is equal to 8. pH is equal to 8, so the hydronium ion is equal to 10 to the negative 8. Okay, it's first step. Well, teacher, now we get hydronium ion concentration. Next, the compound is base or acid? Teacher, the compound is base. So we cannot convert hydronium into concentration immediately. We should convert hydronium into hydroxide, then hydroxide into concentration. Why? Because of the compound is base, so there is a relationship between OH and concentration of base. Okay? We have a plan to calculating OH, but we have hydronium ion. We have a plan to calculate the concentration, but we have hydronium ion. So we should convert hydronium into OH. this equation is KW equation. So OH is equal to 1 times 10 to the negative 6. Well, teacher, now we have OH. So next, calculate the concentration, and after concentration, number of mole, and number of mole after that is gram, will be gram. Look how we can calculate the concentration. OH is equal to number of OH in the CaOH by 2 structure times to the concentration of CaOH by 2 structure. We need to find out the concentration. So the concentration is equal to, there is two hydronium ion concentrations, so it should be divided by 2, the hydroxide ion. So the concentration is equal to 0.5 times to the 10 to the negative 6. So this is concentration. Now we have to convert concentration into number of mole. Okay, mole is equal to, through molarity equation, mole is equal to 1 times 10 to the negative 6, then mole into mass. Mass is equal to mole times 2 molar mass. Do we have molar mass? Yeah, we have molar mass. So I'll show you the brief solvation of that step. Look, gram, we can convert gram into mole, and vice versa. Then mole into molarity, and vice versa. Then, if it's acid, we can get hydronium ion, and if it's base, we can get OH. So we can do OH to concentration, concentration to OH, OH, or hydronium to concentration, concentration to hydronium. Then we can make our conversion between hydronium and pH, and we can make our conversion between POH and OH. So this is general thing. It's very important. Look, we have pH. We converted pH into hydronium ion. Because of the compound is base, so we should get here. We have to convert hydronium into hydroxide, then hydroxide into hydronium, into concentration, then concentration into number of mole, then number of mole into grams. So it will be solved just like that. So draw this scale. It's important, and it helps you in any question. How to solving this question? Just draw this consequence, and you can just select your given, your known, and select your unknown, then choose the way to calculating. بەم شێوەیە کۆتایی بەوانەی ئەمڕۆ دێنین تاوانەی داهاتوو بەخواتان دەست پێرم هەر شاد و سەرفراز بن خواتان لەگەڵ